Hey everyone, I hope you're all doing really well. June was a huge month at Exercism. We had the launch of Premium, our 10-year anniversary. We're about to launch our new newsletter. We've got Exercism perks, absolutely loads going on. We also had the Summer of Sexps, or S expressions, in which lots and lots and lots of people have been exploring the different lisps and experimenting with everything as part of that. So if you took part in that, I really hope you enjoyed it. We're now on to month 7, which is the 6th themed month. We didn't have a theme for January. We weren't that ahead of the game. And for July, we've got Jurassic July. So what do we mean by Jurassic? Well, we don't mean that these languages are extinct. Many of them are still very, very well used today. But although you probably won't be writing too much new software in Cobol. But these are the big sort of foundational languages. They're the languages that set the scene for everything else. So we mean Jurassic in a complementary way. They're the old school languages. Yeah, hopefully you're going to have some fun playing with them. So what languages are we talking about? We're talking about C, C++, Cobol, Fortran, and Visual Basic. Now, we already looked at C and C++ back in Mechanical March. So if you're interested in learning about those, Erik taught loads about them. Yeah, you can check that out in the video for Mechanical March. We also had a great interview with the creator of C++, which was a real privilege to do. You can go and check that interview out as well. It's on our YouTube channel. So as normal, you can get the badge for this month by completing any 5 exercises in those different languages. But if you would like to get the year-long badge and top up your languages, top up your exercises this month for those, there are 5 exercises that we're recommending you do. They're probably also good exercises to do, even if you're just wanting to try one of these languages this month. So the first of those is Bob, classic Exercism exercise. If you've not tried Bob in another language before, then you've been missing out. So definitely give Bob a go. Also allergies, where you get to work with strings and numbers and bitwise operators. We've got reverse string, where you take a string and reverse it. Pretty self-explanatory. High scores, where you're iterating over arrays of numbers. And then finally, Armstrong numbers, where you're working with numbers and looping and iteration. So these are some, probably some more of the standard Exercism exercises. They're pretty common across tracks, but they're really interesting exercises to explore how these different languages have approached them. So I'm joined by Erik, as always, sitting patiently in the corner. Sorry, Erik, how are you?
I'm doing good, thanks.
Awesome. So you've obviously been researching these languages. I don't think you were either a Fortran or a Cobol expert before we started this. What's been your sort of overarching sense as you've been researching these languages?
Yeah, these languages are quite varied. They're still used today in lots of software, even though, as you said, you're probably not choosing Cobol as your very first language to write a new project in. But some of these languages are actually still being kept up to date. You already mentioned C++, but the same also goes for Fortran, which have specifications that are still regularly updated and modern features are added to them. So even though some of them are, 60 plus years old, they don't actually feel that old because they still have newer features. Mm-hmm. But there are, of course, elements that haven't stood the test of time that well. So back in the 50s, when, for example, Fortran and Cobol were developed, there was still, programming was fairly new. And there was a lot of research going on into how should we actually be building our computer programming languages to make it optimal for us. And with research, there were a lot of things that worked really well. And there were some things that worked, less well. So one of the things that I found out was that Fortran initially had a implicit mode, which meant that you didn't need to define the type of a variable if it started with certain letters. So if it started with an I, J, K, L, M, or N, it would be an integer. So you didn't need to specify the type. So that's quite interesting, but I don't think any languages have actually picked up on that nowadays. So I don't think anybody does that. And for example, Cobol was designed to be really human readable. And they went a bit overboard with the number of keywords. There are over 300 keywords. It's like the polar opposite of a Lisp, which just has a couple of keywords. But they had a clear goal, but I don't think the experiment was entirely successful in that you don't see any modern language using that number of keywords, although there are, of course, languages that use, a fair amount, but 300 plus is quite a lot. So, yeah.
It's crazy. Yeah, that's not something... I think even just learning 300 keywords, it feels like a lot more effort than... although it might make things more readable, it definitely feels like it's a lot harder to get started with. So, okay, let's dig in. So we'll go through in order of when the languages were created. If you just want to start with a bit of an overview, Erik, and we will start with Fortran.
Yeah, so Fortran was initiated by John Backus at IBM. And IBM at the time had a IBM 704 mainframe computer. And that was being programmed with assembly language, which is quite hard. So John thought, well, we should actually come up with a way to make that easier to program. So he suggested we build some things, a new language that made that programming for the mainframe computer easier. And that became Fortran. And the things that they were doing on the mainframe were very specific. And usually a lot of it was scientific computing and engineering applications. So Fortran was designed to be very good at those use cases. So its name is actually short for Formula Translating System. So a lot of formulas in Fortran. And what I found really, really cool was that Fortran was the first high-level programming language. So, and they did some measurements, and they estimated that it reduced the amount of lines of code by a factor of 20. So you can see why that would be a great boon to productivity at IBM. And the high-level language was also something that people were concerned about, because they thought, well, how could it ever be as good as my handcrafted assembly? So Fortran was actually also the first optimizing compiler. So they tweaked the compiler such that it was doing certain optimization passes to, even though you might be writing one thing, the compiler would actually rewrite it to something more efficient. And Fortran was the first programming language that actually pioneered that. It's a static and strongly typed language, and initially only supported imperative programming, which was fine at the time, of course. But as I mentioned, some of these languages were evolving, which includes Fortran, and they added procedural programming quite soon after that, so functions, etc. And later on, they also added support for other paradigms like object-oriented programming and array programming. Array programming is something that you might remember from when we discussed our Python, Julia, and R languages, and the latter two both support array programming. So that's all scientific computing is well designed for that. So then what we have is that the standardization began in 1966, so not immediately after it was released. So the first version is Fortran 66. But the last update was in 2018, so that's 5 years ago. And I was quite stunned by that. So in my mind, Fortran was an old language, and it is, but it's still being kept up to date. So it's quite impressive, actually. It's also a highly influential language. It has influenced languages like BASIC and ALGOL, and basically almost every single language that came after it in some way. So much of the early programming language research was done to help improve Fortran, and that later on that, of course, also applied to later languages. As you probably can infer from the fact that they are still updating the spec, it's still being actively developed. So new features are being added, modern features, but they are very keen on providing very strong backwards compatibility guarantees. So it's almost always the case that old code, maybe 40-year-old code, should still run fine on newer versions of Fortran. So backwards compatibility is key. Fortran has built in parallelism using co-arrays, which is a safe and efficient method of expressing parallel execution in your code. And what I find interesting is that functions can be marked as pure, which is something that we discussed when we did a function of February. And the fact that you could mark a function as pure, we don't need to go into the details, but this is intended to help the compiler to apply certain optimizations, because it gives the compiler some guarantees of things that can't happen with a pure function. But it's built into the language, so quite cool. It has safe memory handling. Of course, it didn't in the beginning, but now it does. It's using allocatable variables. So you basically say, hey, the compiler is responsible for freeing the memory. And that's quite a modern feature too, although it's probably a bit different from what you're used to. And as Fortran is very keen on integrating well with C, it has built-in interoperability with C. So it has a very strong C link.
Very cool. 50 years between the first version, the most recent version of the spec, and I imagine that won't be the last one either. That's really impressive, isn't it? Okay, so after Fortran came Cobol.
Yeah, so Cobol was designed in 1959 by the Codicil Consortium. That was actually sponsored by the Department of Defense. So that was quite a shocker to me. And the goal was to lower the cost of developing business applications. So Department of Defense also has regular business line applications, so blobs, boring business applications. But the name Cobol actually stands for Common Business-Oriented Language. So you can see that the name already suggests that this is meant to solve real-world business problems. It became a standard slightly over 10 years later in 1968. And the latest revision is from 2014. So also it's quite new. And in this case, there are many different implementations. So you have IBM Cobol, GNU Cobol, which actually compiles to C. There's Micro Focus Cobol, Visual Cobol, which runs on the JVM and the .NET runtime. And there are more implementations. And that's probably testament to the fact, well, it has been around for a long time and it is standardized. But you can basically pick and choose whatever you prefer. So GNU Cobol compiles to C, so it's very portable. But if you're already running on the JVM or the .NET runtime, Micro Focus Visual Cobol might be a good thing for you to choose. Cobol is also a statically typed language, and it's also multi-paradigm in that it supports both imperative procedural programming and object-oriented programming. I mentioned this before, but Cobol is very well known for being verbose. Other people would say Cobol is very well known for being very readable. So the goal was to have a very human-readable syntax, and you should be able to give a bit of code to your, your business analyst and explain what you're doing, and they should be able to understand it, even though they might not know how to program. And the goal was to use very English-like syntax. So the keywords are just your regular English keywords, from, to, assign, you name it, etc. And it benefits readability and maintenance, they say, even though it is slightly harder to remember all the 300 keywords. But a good editor can help with that. But it was a noble goal, at least. Like Fortran, Cobol really values backwards compatibility. It has a very stable specification. And it is, of course, battle tested in many applications. So many Cobol programs are still running that have been altered for, sometimes even decades. And they don't need to, because they're working well and they still run on newer versions due to the backwards compatibility guarantees that Cobol gives you. Cobol also has good performance, which is evidenced by the fact that it's used in the financial domain a lot. There was an estimate a couple of years back when that 85% of financial transactions would at least go through some Cobol code, maybe more. So the financial world still runs on Cobol, even though slow efforts are being made to replace bits and pieces, but Cobol is still integral to the financial world.
Interesting. I just checked while you were talking to see. You mentioned in the Fortran bit that the aim was to reduce the verbosity to make less lines of code than say assembly. I just compared the Cobol and the assembly hello worlds on Exercism, x86 assembly, and they both have exactly the same amount of lines to do hello world, which I think is maybe telling. And I'm not sure which one I find more readable. I actually think I maybe find the x86 assembly one slightly more readable than the Cobol one. So yeah, interesting to explore. Okay, so the third language that we're featuring in this video, as I said, C and C++. Check out the Mechanical March video if you want to learn about those. But the third one we're touching in this video is Visual Basic, Erik.
Yeah, so Visual Basic was Microsoft's implementation of BASIC. So BASIC is a quite old language, and it is very well known for the language that many people have used to first start programming in. I think it was actually in MS-DOS, so you could easily start using it. And Microsoft adopted BASIC into Visual Basic, and then later on when they developed the .NET framework, they converted that to Visual Basic.NET, and then later on renamed it to just Visual Basic. So a lot of naming there, but since 2000, I think 3, it was just Visual Basic. So it was released in 2013, I think. The first version was released in 2002, and I mentioned that Cobol and Fortran are still being updated, but that's not the case with Visual Basic. Visual Basic was marked as stable in the beginning of 2023, and this means that it will have no new syntax added to the language. Everything that's already there will keep on working. If there's a new feature in, for example, C#, they will probably add things to be able to use it from your Visual Basic code, but there will not be an equivalent feature within Visual Basic. So it's a very stable language. And they will still support it because a lot of code was written in Visual Basic. As for its syntax, it shares most of its syntax with Visual Basic. There were a couple of tweaks, at least the original, which they now call Visual Basic Classic. It's all very confusing. But it's a statically typed language that supports both strong and weak typing. So the conversion guarantees differ depending on what you want. And it's also multi-paradigm, but it's primarily object-oriented. That's what Visual Basic is known for. But you can also do imperative programming. And what Visual Basic was also used for a lot is to do event-driven programming, where you have graphical applications, you have a button click. So the click is an event. Then you respond to that event. So that's often referred to as event-driven programming. Visual Basic is well known for being relatively easy to learn. Visual Basic Classic was designed to be easy to learn. So they did just a couple of tweaks, so that should still hold. And it has excellent support for object-oriented programming. So that's if you want to do object-oriented programming, Visual Basic is excellent at that. And it runs on the tried and tested .NET runtime. So you get all the benefits of running on the .NET runtime. You basically almost get like an old language running on a newer runtime, which you also have with one of the Cobol implementations. So it's an interesting mix of older heritage and newer code that it runs on. And what Visual Basic also has is a lot of things that C# also has, and that's, for example, easy deployment, where you have something they call click once deployment, which makes you pushing something to the server as easy as just a button click.
Another good thing I think as well with Visual Basic is the use of the integration of the Microsoft products. So being able to use it in Excel or that sort of thing. Visual Basic is still the go-to language for that. I was just reflecting back on, I learned my first programming language was a BASIC. It was Amos, which was the Amiga dialect of BASIC. And Visual Basic actually came out, I think, either just after or just about the same time as that. But it's weird to think how all of the other basics have sort of fallen by the wayside, and this is the only one that's that's still there and still being used and maintained today. So yeah, in terms of use cases, if people were interested in where these languages are being used, maybe they're trying to work out which one's going to be good for them. Where each of these languages used versus the other ones today?
Fortran is often used in high performance computing scenarios. For example, software that runs on supercomputers. There's also a benchmark that tests supercomputers, and that benchmark is written in Fortran. So common use cases would be weather forecasting, astronomy, structural engineering, basically all things that require lots of computing power. And then you want a very efficient language, and Fortran definitely gives you that. It's also used in CAD software to help design things. And it's actually being used indirectly by many other applications. So, for example, if you use NumPy, which is a very famous Python library, under the hood, it will use Fortran 77, so the 77 version, for a lot of its calculations, just shelling out because Fortran is incredibly fast. And there is more software that also builds on Fortran under the hood.
Impressive. I bet not many Python developers know that they're using Fortran under the hood. Cobol, you already mentioned a bit about finances for this one, financial industry.
Yeah. So Cobol, just a lot of enterprise scenarios, so including finance. We'll come to later on why that is. There is a very good reason too why Cobol is very popular in finance. But apart from the regular business applications, it was also used as a key value store at Walmart, so quite big. And those business applications can be anything. So Cobol is quite good at and has dedicated features for generating reports. So I don't know, it's almost like, it's not exactly a PDF, but like structured text with columns, etc. And that can be incredibly useful for many business applications. So basically, any business application could be Cobol, and a lot of finance.
Interesting. And then Visual Basic?
Visual Basic was, the sweet spot for Visual Basic was usually graphical UIs. So you mentioned before that it integrates really well with everything that's on Windows. So you often saw people storing data in perhaps an Access database or just on a file system, and you quickly create a graphical shell for that using Visual Basic. It was used to have server-generated websites, so server-rendered websites, for a while. That has since been succeeded by later versions, and that became C# became more popular. But in the beginning, it was Visual Basic. And the companies that use Visual Basic are wide and varied. Like you have Boeing, Wells Fargo, General Electric. It's just a lot of big customers are still using Visual Basic, even though it's also not the most popular language to start out with. Interesting.
Yeah. I guess once there's that legacy investment in your code base, you're just going to keep going with whatever that legacy is. So at this point, we often talk about the different sort of paradigms that different languages support. I think from what you've said, they're all pretty multi-paradigm, multi-purpose things now, having grown over such a long time. So we won't dig into that too much. But in terms of, say, standout features, what are the different standout features of different languages, starting with Fortran?
So Fortran's standard feature, I think, is its performance. It is incredibly optimized. The very fact that it runs on those supercomputers gives you an indication that people think it is really optimal. And we mentioned this before when we discussed Julia, that there is a club of languages that process, I think it was 1 petaflop floating point calculations in a second. And Fortran is part of that club. So that's a very elite club. C is also part of that club. So performance is excellent in Fortran. And the language itself, the data structures, the data types have all been designed to support efficient calculation. And one of the benefits of having all this huge, 60-year experience is that they've also been able to see what works and what didn't. So some features might be superseded by newer features that work more well. but it will be based on actual data. So that's one of the benefits of all the languages, that they will have stood the test of time, and there will be a lot of experience. And that has all been adapted to make Fortran an incredibly performant language. Fortran is also, of course, great for doing computation, so scientific and several mathematical applications. So there is a wide range of mathematical functions that it supports. I mentioned that the NumPy uses Fortran under the hood. And basically, it's what you want if you're working in a scientific environment. So you get all the mathematical functions that you really like to use, and Fortran provides you with those. And then the third thing is that it supports array programming. So when you're doing research, you often have arrays because you have measurements, etc. And you you have vectors, if you're doing AI, for example, and you want to apply operations to maybe add two vectors, multiply them. And if you would do that in a language that doesn't support array programming, you would probably iterate over them row by row and then column by column. But with array programming, you can actually just have an operator that will do vector 1 plus vector 2, and then you would get the new vector. So array programming is like you can apply the operators that you're used to doing, working with, I don't know, single scalar values, so two numbers, but you can apply them to arrays without any changes in your code. So array programming is really, really neat. Julia and R have that too. And if you work a lot with arrays and vectors, then it's something that really it saves you a lot of code.
Yes. I wonder if NumPy is using the array programming bits of Fortran as some of the stuff it's using under the hood, because that's such a big part of what NumPy does as well. So Cobol, you've talked about it being widely used in finance. Why did it get such wide adoption in finance? What are its standout features that made that happen?
Yeah, one of the reasons is that Cobol supports fixed point arithmetic. So you're probably well familiar with floating point arithmetic. And there is a really nice website that shows you that rounding in floating point numbers is maybe not what you think it is. And you definitely don't want rounding errors when you're working with finance, because if you have, I don't know, the 10th decimal after either 0 or whatever, you don't want to lose that when you're doing very big transactions, but you want to keep that. A fixed point arithmetic doesn't have rounding errors. It's a different way of dealing with numbers that can have decimals. So this makes it perfect for finance, where I don't know, if you're on the internet and you have a rating website, it doesn't probably matter that you get these little rounding errors, but for finance, it really, really does. And Cobol has fixed point arithmetic, and that really helps in the financial domain. Another feature that Cobol has that it's excellent is that it is great for reading to and reading from and writing to files. So they call that records, and that sounds silly, but it isn't, because Cobol was really designed to be very good at that. And at that time, that was quite unique, because it was business-like. It was something that you have real-world usage for. It's not just doing a calculation, or not just a calculation, but Cobol made it, the support for files made it an excellent tool for any business application where you need reading files, you need to write reports to files, and Cobol got you covered, because it has excellent report generating functionality. So there are dedicated constructs in Cobol to define a report and to populate it with data, etc., without having to do all the nitty-gritty formatting yourselves. And this is also one of the reasons, of course, why business applications like this so much, because reporting is key to any business application.
Of course. Really interesting. And then Visual Basic?
So Visual Basic standard feature is its ability to quickly build a nice looking GUI. So that was done via Windows Forms. I've used it quite a lot myself too. And it's what you see is what you get editor. And you could very, very quickly create a form, drag up a couple of buttons, click on them to have event handlers be generated. And in no time, you would have an application that was visual and that would interact with, I don't know, your file system or a database. And all the visual aspects of it were really, really easy to build. And this made Visual Basic excellent for not only just prototyping things, but also for, well, business applications, because it is much easier to have a graphical tool than just to read some text. And Visual Basic was excellent. And the second standard feature is sort of tied to that, in that you build these applications in an editor, which was Visual Studio. And there are now other alternatives, but it was back in the time, it was mostly Visual Studio. And that's a very rich IDE. So you got a lot of rich editing support. You got code completion. You have the what you see is what you get editor itself was very fancy, where you could have docking rules, where if you would stretch the screen, it would automatically expand or contract, etc. So you could build very fancy UIs just by clicking around in the editor. And you wouldn't have to write any logic, because it would be in the system itself. And that made Visual Basic a really appealing choice when you built a GUI.
Mm-hmm. Nice. So if someone is trying to decide which language to do during July, obviously C and C++ are available as well, which we've not talked about. I know lots of people want to give those a go. But just thinking of these three languages, where might you recommend somebody tries each of these languages, Erik?
Yeah, so if you're interested in doing scientific computing, high performance related code, I would recommend Fortran as an option. It really is an old language that has been updated to modern standards, but with still excellent performance. So there is a lot of things that you can do in Fortran to make your code really, really, really fast. So if you're into that, Fortran will be an excellent choice. If you are into business applications, or you'd like to see how we used to write business applications a lot, Cobol will be an excellent choice. If you want to see what it feels like to work with 300 plus keywords and see if that does improve readability, maybe you think this is the best thing ever. It could be. A lot of people were really, really keen on those keywords. So try out Cobol and see if you like it. If you like to build a UI, a graphical UI, and you want to just quickly prototype something, Visual Basic is an excellent option. Especially now that you don't have to pay for Visual Studio. There's a free version too. Or if you're already on the .NET platform, Visual Basic might also be a logical choice, because you can interrupt with all the code you've already written. And if you're interested in the history of programming, basically all three languages could be chosen. Although Cobol and Fortran are slightly older, so they have some of the, you get more of the feel of the time where they were still prototyping things and trying out different language design elements to see if they worked. So they're different languages from what you're used to. So if you're interested in how we used to program, and also how we still program in parts, but back in the days, this was just everything that we used, go check out Cobol and Fortran.
Awesome. Thank you so much. I'm really interested to try Cobol just to see how it feels to just be in a keyword dominated world. But also, you've changed my perception of Fortran quite a lot in this video. I didn't realize how sort of modern in terms of performance and things it was. So
I didn't know beforehand either. So
yeah, thank you for opening my eyes and a bit there, Erik. Cool. Well, that's the video. A bit shorter and sweeter than normal, but hopefully a good introduction for you all. Let us know in the comments, as always, which of the languages you're going to try, and I hope you have lots of fun. Do post on our Discord and our forum as well, and chat to other people that are trying them out, and we can all have some fun exploring and learning together. Have a great week. Thank you for watching.